All right, guys, again, welcome to another lecture. Before we solve this exercise where we want to show that limit as x goes to 4 of x squared is 16 using a delta epsilon argument, would anybody like to recall what is that argument about in very simple terms? What is it that we're trying to capture? What is it that we are trying to convey? Anyone? And guys, you see, if you have to look at the notes for that, that means you have not understood it. That means that it is not as obvious to you. If I asked you, what is the color of zebra, you would say it's black and white, right? You don't have to think about it too much. You have seen it and you remember what it is. So again, guys, here is the idea. Ibad, that's a bit vague. Yes, what is that idea about the pipe? Again, let's go back to the delta epsilon idea and remember what is it that happens when we calculate limits. So when we evaluate a function at some point C, what we do, we just, we can imagine it's like a water turret, and we take this particle C, we feed it into the mechanism shoots the particle and it lands on the wall at position F of C. Is this part clear, guys? If so, type yes. If this first part clear about what it means to evaluate a function. Beautiful, right? It's not such a complicated analogy, I hope. So what is it that we do? Forget about water or anything, but what is it that we do when we evaluate a limit? What we do when we evaluate a limit, here it is, right? We are selecting C-like numbers that we plug into the function. So we don't plug C, but we select numbers that are a close approximation of C, correct? And if we claim that the limit is L, that means that the outputs become close approximations of L. And I like to call it plug in a C-like number and get out an L-like number, okay? Now, what is a C-like number? What is an L-like number? That's a very vague term. L-like, C-like. It depends on your definition of precision. Okay, guys. So your calculators, for example, all right. If you ask the calculator to compute the square root of 5, the calculator will display a bunch of digits. Maybe it will display 8 digits after the decimal point. It will never display the entire number root 5. It's actually impossible to do. Maybe we might have a lecture about it later on. It displays a truncation. Are you so far clear with what I'm saying, guys? It displays a truncation. So if it is displaying only 8 points after the decimal space, then let's say you might say that the 9th point cannot be detected by your calculator. So that means that the number that is displayed on the calculator plus minus, let's say 10 to the minus 9, right? 10 to the minus 9 is your representation of precision. Now, what is the number plus or minus 10 to the minus 9? That creates an interval. Do you see? So I think of that interval as a pipe. And if I launch a particle near C somewhere, right, and it lands within this red pipe, then the detector, the machine, is not able to say whether or not it's L. So it concludes that if it enters this pipe, it concludes that the value is L. You understand? Let me give you an example. Very simply, how many digits do you know for pi? Tell me, pi is, you don't need to give me tens of digits, don't search in Wikipedia, just from your head, give me your best approximation of pi, please type in the comments. Okay, David Weng said 3.1415. So some person said 14159. Some people gave quite a lot of decimals, and 0.1314. You don't mean that's pi. Lisa 3.14. So most of you guys remember two digits. You say 3.14. Some of you remember 3.1415, and some you remember even more digits. So you see, is pi equal to 3.14? Most of you, well, I hope you will say the right answer. Is pi equal to 3.14, right? Yes or no? So Dragon says no, Steven says no, David says no. A lot of people say no, okay? But you don't remember the other two digits. Let's say you don't remember the digits that follow, correct? Most of you, well, some of you remember more digits, but let's say you don't remember the digits that follow after 1,4. Okay, that means that I can give you a number that is not pi. For example, I can give you 3.147 or 3.105, right? I can give you plenty of continuations of the decimal that will not be pi, they will be pi-like. So you see what would happen. So the numbers that I can give, if L is 3.14, you see, now let's say if you don't have the ability to detect more decimal places, so that means that perhaps your resolution is 10 to the minus 3. You understand? So this number plus or minus 10 to the minus 3 looks to you like pi. Does it make sense what I'm saying so far, guys? So that's your error. If I say 3.14 plus minus, let's say 10 to the power of minus 3 might look to many of you like it is a pi. So what is that 10 to the minus 3? That is the epsilon here, okay? So let's say this is the actual pi in the center, and this is the biggest error above pi that you can tolerate, and this lower wing is the smallest, is basically is the error in the negative direction. You understand? Are you following what I'm saying, guys, so far? Please respond. Okay. If you don't hesitate, stop me for a moment. You understand where I get this interval? So this red interval is the tolerance of error. So if I select, you see, if I select any number in this red interval, you cannot tell that it's not L. Okay, if there is any number in this interval, it looks to the detector like it's L, because L has a limited ability. So everything in the red is presumed to be L. Obviously, it's a subjective thing. It's a detector, right? So somebody that has a better resolution for pi, some people say 3.1415, right? So I know at least four places after the decimal point, right? 3.1415. So that means that my epsilon will be smaller. I could detect, if you give me the number 3.1417, I know it's not pi right away, right? But if you give me 3.1415 and a bunch of other digits afterwards, I might not know if it's a pi or not. I will consider this a good imitation of pi. So the idea is that this red zone is for the particular detector what cannot be detected as not being L. So any particle that lands into this pipe is assumed to be L. Good? So what happens in the limit? What happens is that if I squeeze the interval smaller and smaller around C, I expect that the current, the blue the blue lines that hit into the red pipe, they will be narrowing around the point L, which means I could take the red pipe smaller and smaller and smaller. And then when I take the red pipes thinner, that means I can recognize L to higher degree of precision. The idea that the limit converges to L means that no matter what's your degree of precision, even if your degree of precision is very high, that means that the red pipe is very thin. Eventually, you are no longer able to tell me whether or not we get L or something that is not L. So if you understood this, please write yes, no. It's an easy idea, guys, right? You understand how I communicate in terms of a pi, so in terms of pipe. what a limit is, right? So I want to say that the current, the water current that I'm launching is entering this red pipe, no matter how thin that opening of the pipe is, and it's launched from some thin pipe on the x-axis. You understand? So the thickness, the radius of the horizontal blue pipe is the quality of approximations to C. So the thinner the blue pipe around C, the better are the approximates of C. And the thinner the red pipe, the better are the approximates of L. You understand? So the idea of the limit is you just have this idea that you communicate as if you were a plumber. Okay. So limit exists if what? If you install a vertical pipe, and no matter how thin it is, I can squeeze the horizontal pipe thin enough so that the entire water current coming from this thin pipe, say for the point C, say for one particle, is landing into the red pipe. You understand how the idea works? So you communicate using plumbing this idea that the beam coming out of the turret is very focused around L. You follow what I'm saying? So that's the delta of epsilon. So what you have to do is somebody opens up this pipe, and if you can show that no matter what pipe was opened, you can select a delta of epsilon. That is, you can squeeze the input pipe thin enough so that the current enters the target pipe. That proves that the current can be focused around L. I hope you understand this idea. It's very simple, right? Once you see a picture of it, it should be very simple. And it's not, by the way, that you just try to understand mathematics. Some people, again, they have this very narrow view that, oh, I'm learning limit or I'm learning calculus. What I think you are learning, if you are learning, there are very few people that actually accomplish that. Even people that get A, and people ask me for recommendations all the time. And that's why I'm actually mentioning this. You see, it's actually, it became harder for me to write those recommendations because my true opinion usually when people pass calculus, even with A+, is I think, oh, the person passed the calculus. And it is maybe an achievement for them, but maybe not, right? Maybe they haven't really learned it. And I am not a very strict grader, and I try very hard, and I feel bad for you if you are not doing well. But you see, all of this kind of gets to me, right? I just feel like when I write a recommendation, and then when I do, I always write it very well. Frankly speaking, when I write it very well, I lie. And I don't want to lie, right? I really want you to, I don't know what it is. Socrates says that lying is just harmful to your soul. It does, it eats at me somehow, right? I don't want to lie. I want to tell you what I really think, and I want you to also be honest, and I want you to understand something. Yeah, so the question about the exam, don't worry, it will be announced at least 2 weeks ahead of time, and you know, it's a take-home exam, so you will have time to do it. And that's one thing about it. It's a take-home exam, so it's really trivial in some sense, right? I'm sure many of you will do well, and I'm sure that many of you, well, I hope. I mean, that's pretty much all that remains. Statistically, I don't believe that, but I hope that you will open your eyes, you will become interested in things. Okay, there are many interesting things. It's a sort of thinking that I want you to enjoy, not really calculus or a particular subject. And it's one of the very few things in college that you can actually learn, right? I've taken, I don't know, when I was in college, 200 something classes. I've been in psychology, I've been in philosophy, I've been in all sorts of things, right? Very few things that I truly learned. Mathematics was perhaps one of those few things that I actually picked up. So anyhow, good guys. This is the drawing. This is the delta. You just have to adjust the delta, make it smaller and smaller, and the epsilon is fixed. So you have a particular pipe. You want to, can you focus it to within to enter this thin pipe? Can you, and if you can do it for an arbitrary pipe, that's why we have epsilon, right? Because the idea is if you can do it for any pipe, if you can make the current go into any pipe, that means that the red pipe can be very thin, as thin as you like, and the current can still be made to enter. Just that communicates the idea of focusing the beam. Good. So do you remember how we solved those examples, right? So we have x going to -2, 5x plus 2 equals to -8. How did we do that? Let me just remind you how the idea went. So we try to communicate because we're blind. We don't see how the current looks like. We are just listening to communications about it. It feels almost like you're landing a module on on Mars, right? You cannot see it in real time. What you have to do is the machine sends signals. It tells you whether some procedure was carried out. It's a very, very similar situation here. The current you don't see. You're trying to figure out based on this reports, this telegram, what is truly happening. So in this case, limit as x goes to -2 of 5x plus 2. The actual particle launched at x will land in position 5x plus 2 on the y-axis, okay? And what I want to do is I want to know how close did it land from the target being my limit value -8. So absolute value of 5x plus 2 minus -8, or absolute value of 5x plus 10, it's just a measurement of the distance between the target and the actual landing zone of the particle. Okay, where did the particle go? Where did it land? I hope I'm clear, guys. Right, I don't see your faces, so I don't know if I am clear. Right, I might say several things maybe redundantly, maybe not. I have no idea. So what happens then is you imagine that you were closing the blue lid, you were closing the input pipe, and it became somehow thin enough, you just don't know how thin, and you observe that the particle, a particle randomly launched from the x-axis, lands within epsilon units away from -8. You follow me? Which means the particle has entered the red pipe of radius epsilon. Because think about it, right? Here is that picture again. You see, what's the distance between this blue point at which I this point where the arrow is hitting and L? The distance is clearly less than the length of the wing, and the length of the wing is L plus epsilon minus L, which is epsilon. Or if it hits here, what's the distance? Also less than the lower wing, and the length of the lower wing is L minus epsilon, and difference between L and L minus epsilon, so its length is also epsilon, okay? So that's what I communicate algebraically, so to speak, here. The particle, I'm not seeing those inequalities, I'm just saying the particle landed in the red pipe. That's what I see in my head, okay? And then the question from there is, where did the particle start from? How close was the particle to -2? And that's communicated by absolute value of x plus 2. Absolute value of x plus 2 is just, this is the distance between x and -2, because it's x minus -2, good? And then I see I can factor out a 5, and I get this expression. So then dividing by 5, I get that x plus 2, the distance between x and -2 has to be less than epsilon over 5, which means that the blue pipe has to have radius 1/5 the size of the target pipe. As soon as that is happening, the current is entirely exiting from the thin blue pipe and enters the red pipe. You understand? So you have a procedure. You know that if the radius of the target pipe is 1/2, you have to select the radius of the domain pipe to be 1/10. It has to be 5 times as short. Make sense? 5 times thinner. So this is what we talked about last class. Easy idea, guys. You understand? If you think about what it is, and it becomes enjoyable because you see you come up with those analogies. You just you see relationships between. It's like an encoded story, if you like such ideas, right? It's like somebody sends you a message, and who knows if the message is interesting or not. But because it's encoded, somehow it makes there is a shroud of mystery about it. You just want to open up. It's like a closed envelope or a closed gift, and you really want to open that thing. By the way, a fun fact about gift. You know what gift means in German? Take a guess what gift means in German. No. Well, maybe it does mean math, Dragon. Any guess? You might mean the same thing, you know? No idea? Punishment? Maybe. So if a German comes to you and says, I have bought a gift for you, right? Ich habe ein Gift für dich. What would you say? Would you be happy or would you not be happy? It might be food, perhaps. Not happy? No, I'm not sure. Maybe you're wondering, what is this strange old person talking about? So das Gift in German means poison. Okay. So yes, and sometimes that actually feels like that. Sometimes you get something like that and you know it's a poison. Okay. So yeah, it's another thing called false friends. There are many false friends, right? So people are nice to you, but they are not your friends. Anyhow, so back to the material. Now let's talk about limit as x goes to 4 of x squared equal to 16 to your best ability. And we did it a little bit in the last class. Try to see how far you can carry the argument. There will be an extra credit, I think, about delta epsilon. And again, be careful if you answer it, right? I might actually test whether you actually answered it. All right, Zainab, I will definitely go there. Don't get lost, guys. So again, this question, how do I know that epsilon is, anybody would like to answer this? And by the way, please speak up, I'm speaking, right? It would be really nice to hear your voice. What is the statement? How do I know this? Okay, so back to this delta epsilon argument where x goes to -2, 5x plus 2 equals to -8. How am I concluding this line? Come on, help me, guys. How am I saying epsilon is bigger than absolute value of 5x plus 2 minus -8? When you say it's because of x, I'm not sure what you mean. Zainab. Guys, simple question, you see, right? If you understand delta epsilon, how am I starting this? What's the idea? Nobody? That's the thing about it, guys, right? So you see, it's a, here is again the idea, right? You're doing algebra, guys. It's not an algebra here. It's like, it's like we need to replace your graphics card. That's how I feel, right? Just there's a graphics card here, and you should see something, right? It should be very visual. Do you have dreams, guys, that are so vivid? It's dangerous for me to drive. I can start thinking about something. I stop hearing. I stop seeing. I can be transported entirely into a different place. So that helps. Right? You see something very vividly. It's the same thing as when you paint. Here is what happens here. What I'm imagining is that, well, there is no reason why that might happen. I'm basically saying this. Suppose that I'm closing the lid. Imagine you're playing around with it. You're closing the opening of the blue pipe. You're making it narrower and narrower and narrower, but you control it like in a submarine, right? You close the valve. Can you imagine that? Like splashes, right? Can you imagine you're in the submarine, right? And everything you have here, you cannot use your senses. You don't see. It's a different universe, right? So you're closing this this pipe, and then you have sonar information. And then you understand that in the sonar information that you are told particles. This means this. You closed enough, particles are landing within target. You understand? Particles are landing within target. It's like you are in a U-boat, in a submarine, and that's actually how they had to be very gifted mathematically. You know, you shoot at a ship without seeing anything. You understand? You have this sonar, and you are using your equipment. You are completely blind otherwise. You're using sonar. You're using machinery to tell you whether or not you hit. How fast must you launch the torpedo? Timing it. You understand? You should watch maybe the movie U-boat. Das Boot, it's called, right? Or there were American movies like that as well. So that's really what's happening here. This line means that suppose you did something, you closed the input pipe, and the points, the particles are landing within epsilon away from the target. You understand? Are you with me, guys? Joshua, epsilon has to be bigger than that, because that means the particle, the distance between particle and target is less than the radius of the pipe, and that means the particle entered the pipe. You understand? That's how we communicate it. Are you following me, guys? Some of you look lost, right? That's the problem. I want you to have a very vivid imagination. You understand? You can imagine all those things. That's why it is more interesting to me than maybe to some of you that don't imagine it as much. Do you understand? How do I know that that the particle entered the pipe? It means the distance between particle and center of the pipe is less than radius of the pipe. That's how we communicate it, right? So what I imagine happening here, where the pipe is given to us again, here, guys. You see? Here is that pipe. I first ask myself, what does it mean for a particle to enter the pipe? It means that the distance between where the particle landed and the center of the pipe is less than epsilon. Do you agree? Are you with me, guys? Or are you completely lost? It's the morning and it's kind of difficult to do anything in the morning, at least for someone like me. You say yes, I hope so. More or less. It's a relationship. Epsilon is, again, we spoke about this focusing, right? So what you have is you have a detector, and the detector, it has a particular pipe. We are trying to fool that detector. We're trying to convince that the detector that we're always hitting the target L. You understand? So each detector has a particular pipe opening, because just like I mentioned with 3.14, is that if you are detectors for pi, your resolution is maybe epsilon equal to 10 to the minus 3. You understand? Because you cannot tell the digits coming after the second digits. First digit is 10 to the minus 1 after the point. Second digit is 10 to the minus 2. Third digit is 10 to the minus 3. If you don't know the third digit, it's like that's your resolution. You only see those two positions. Are you following me? So you are, as a detector for pi, most of you, your epsilon would be maybe 10 to the minus 3. If you are better, you know more digits, it might be maybe 10 to the minus 5. If you know more digits, it might be even maybe 10 to the minus 8. Who knows, right? But every single one of you is a detector with a particular pipe. Okay, and the idea is that if I squeeze the input, I can fool you to think that I'm always hitting L, and the idea is then that I can push the current into the pipe. Are you with me? I think my explanation is intuitive, but that's just, again, I understand it. That's all it means, right? Do you understand my explanation, guys? I hope you do, right? I think it's pretty good, but. For the value part C, what part of the equation is that? But we'll see it below, Joshua, okay? Again, we'll see that below. So you understand this idea. Squeeze this. Forget about, you see, how you remember things, right? Forget about all the complicated mathematics. First, imagine that what you're seeing is this completely visual. You're seeing the input pipe getting very narrow, and then you're seeing this current getting very narrow. That's I tried to draw. Here it's not very narrow. Here a bunch of water molecules are not entering the pipe, and here they are still not entering the pipe, but this is a more focused current. And finally, if I make delta even smaller, the current is entirely focused and enters into the pipe. Yes? And the idea is that I will be able to do that for any pipe. What is that? What is the pipe? The reason I have this pipe is that that's your delta, that's your approximation quality for C, and this epsilon is your approximation quality for L. So the idea is, as I improve my approximation quality for C, that means as I squeeze this input pipe, I will improve my approximation quality for L. That means that the current will enter into this red pipe no matter how thin it will be. If I can make it thinner, then I'll have to squeeze the input interval even more. Good? So again, back to this this particular question, right? With where is it? Here, x going to -2 of 5x plus 2 equal to -8. What do we have here? We're saying that here, this x, when you see 5x plus 2, that means if I put a particle x into my gun, the particle lands at 5x plus 2. Okay, and I'm claiming that if the particles are close to -2, they land close to the -8 point on the y-axis. And so here I try to construct a delta epsilon argument. So I imagine when I construct this first line, I imagine I closed the valve, the input valve enough, and I haven't paid attention to it. I don't know how much I closed it, but I start realizing this is what this line means. Suddenly I see this is the signal that I should start hearing, right? I hear the signal that 5x plus 2 landed close to -8. And that means that absolute value of 5x plus 10 is less than epsilon. That means that the particle entered the pipe, the red pipe. And then I ask myself the question, what have I done? Where was the particle x? In what pipe has it been? How thick was the input pipe? That's what I want to know, right? And so I need information about the distance between x and -2, which is absolute value of x plus 2. That's what I'm seeking. From this line, I'm saying, okay, if I was able to get the particle to the pipe, how close was the particle to C? Or to -2 in this case, that's our C. Okay, so 5x plus 10, I factor out the 5. I have this x plus 2 here. I divide by 5, and I see that x plus 2 had to be less than epsilon over 5. And you can see that you can go in reverse. If I multiply by 5, then 5 times x plus 2 is less than epsilon, and that will imply that 5x plus 10 is less than epsilon. That implies this line. You understand? I can go in reverse. So I was able to construct this correlation. I know how, now I know exactly, I'm very conscious now of how thick must be the input pipe to get the current into the output pipe. We don't have x approaching 0. In this case, we have x plus 2. We don't have an x in this equation. We don't isolate x for this part. So guys, do we need more, or you get my explanation about 5x plus 2? Let me know, please. That side is x plus 2. We want x plus 2 to be very small, yes. So do you understand, guys, the explanation, or are you completely confused? I need to know. I only see, did the others just tune out? Well, still, I don't think it was 30 people, but I don't know. What was this? Not the target pipe, Ibad. We are imagining that for a fixed target pipe, we were able to get the current go into it. So then we ask ourselves, how thin must the input pipe have been to have accomplished that? So we think in reverse. You know, it's very simply, it's like you're tweaking around, you're playing around with this mechanism, and you found out that somehow you made it work, and then you start being aware. How exactly have you made it work? That's the idea of the proof here. Well, the next question I will explain in a moment. Do you understand the idea, guys? Right. The first thing that all those examples are not. I will never use a delta epsilon to this argument. I will never prove using delta epsilon that as x goes to -2, 5x plus 2 goes to -8. This is just a trainer. I just want to show you how the idea works. Right. So it's delta epsilon is not useful for those examples. It is just a trainer problem for you to understand what delta epsilon is, hopefully. If you do it, so you're already going a little higher than where you are. Good? So the next problem is more challenging. But would anybody, before we go and talk about it, would anybody quickly try to, maybe, what can you say about it, right? Try to play around with this example another 2 minutes, and then we'll talk about it. Use delta epsilon argument, show that this limit is 16. Dragon, thank you. So Dragon says E divided by x minus 4. Let's see what the rest of you say. And Alexa Pinea says E divided by absolute value of x plus 4 is bigger than x minus 4. Thank you for your answer, and see if anybody else has anything to say. By the way, let's just see. Edwin Juarez, are you here? If so, type yes in the comments. Good. Khalil Ureman, are you here? Well, okay, Ibad, thank you for your comment. So again, you say like some others above. And a lot of you, how many of you agree with let's see. How many of you agree with Alexa that if I take epsilon, I just need to divide it by absolute value of x plus 4, and then I just get x minus 4. Okay, I think a lot of you at least went somewhere. So thank you for your contribution. And I am sad to inform you that nobody has answered it correctly. but it's not bad. It's the first time you see it, so I was not expecting that you do. But how do you know right away that this answer cannot make sense, guys, right? Even if you don't know how to prove it, how do you know that epsilon divided by x plus 4 is not the valid delta? It has an x, Joshua, precisely. And what does it mean to have an x? Look at it, think about it, right? That's what I mean. If the equations, they become alive for you, then it will not, here is the solution, I expected it. So many students go like this, right? So first step, they say, okay, epsilon is bigger than x squared minus 16. Would anybody dare to write in the comments or speak? That would be so wonderful to hear your voice. Tell me why. Well, what's this first step? How do I accomplish this first step? Why do I say epsilon bigger than absolute value of x squared minus 16? You understand? Yes, but that's algebra. You understand? It's not an algebraic reasoning that's happening here. What is, you see, is this step arbitrary to you or not? What is it? Does this communicate? Yes, exactly, David. Okay, so what is this first step communicated? It's you are thinking in reverse. You understand? It's not by mathematics that you do that. You are supposing that you played around, you were playing around, and suddenly you were able to squeeze the interval. So you made the input pipe about 4 thin enough, and you just was not paying attention to it, and you just realized that all the particles in that input pipe are landing within 16, landing very close to 16. In other words, they're landing into the target red pipe. And then your question is, what have you been doing? How thin was your input pipe? What was the proximity of x to the number 4? So I'm looking at x minus 4. That's what I want to find out. So students go like this. Epsilon bigger than absolute value of x squared minus 16. X squared minus 16 can be factored into absolute value x plus 4, absolute value x minus 4. And I need information about how small is x minus 4, how short is the distance. So they go ahead and divide by absolute value of x plus 4, and they get this delta of epsilon. Epsilon divided by absolute value of x plus 4, and that's bigger than x minus 4. That's the size of the pipe. Now, could anybody tell me right away without knowing what's the right answer, why is this answer impossible? Why is it not correct? What's going on? So one person said there is an x on the bottom. Why does it cause us problems? Having an x on the, having this absolute value of x plus 4. Well, but that's vague, Ibad. So you can have more than one x value, yes, but what is actually this doing? Can you imagine? You understand? So when this should translate to a picture, what's happening here? All right, let me help you and explain what happens here. So this delta has an x. Precise point, again, we speak about the pipe. This is the radius of the pipe. Now look at it. The radius of the pipe varies. It changes with every x that I launch. So for example, if I launch x equal to 4.01, I have epsilon divided by 8.01 because x is just 4.01. It gives us this denominator. Do you see that? If x is 4.01, we get the denominator equal to 8.01. And if x is even closer, 4.001, I get an entirely different denominator and therefore a different radius. So what happens here is that with each x that you're launching, the pipe is changing its size. That's not how we imagine. You're not going to change the pipe for each different x. No, we have to fix a pipe. It has to be fixed plumbing, fixed input pipe. The output pipe is of radius epsilon. The current from the fixed pipe is rushing out and entering the red pipe. Do you understand? So you understand what I mean, guys? Why is it so clear to me right away that's a mistake? Because I understand the meaning. It's not just pure symbols or strings. I see a connection between them. So I look at it and I right away translate it to a picture. I see, okay, what you did is that with each X that you're launching, the input pipe is wobbling. It's getting larger, smaller, and that's not at all what we want. Good? So how to do it correctly, that's a bit difficult on the first try, but let me explain to you. Okay, so do you agree that the pipes I'm working with, the input pipes delta in my toolkit, I really want only thin pipes because X is going to 4. So this pipe is going to be short, right? So I might as well suppose this pipe is never bigger than 1 unit. You understand? I can suppose that it's never bigger than a half a unit. I decided to focus on 1 unit here. Make sense? So that means that X minus 4 in absolute value is always assumed to be less than or equal to 1, let's say, or maybe even less than 1. You can replace this by less than 1. So if that's the case, then I see that X minus 4 is always between 1 and minus 1. Is this clear, guys? Absolute value means the distance of this number, the distance of, if you can call this number Y, its distance from 0 is less than 1. So the number has to be between minus 1 and 1. And so X has to be between 4 minus 1 and 4 plus 1. So X is between 3 and 5. You see, I'm trying to figure out the values between the values for X plus 4. So then I put X plus 4 here, and it's 4 plus 3 and 4 plus 5. So X plus 4 is between the numbers 7 and 9. Good? And that means that the absolute value of this number is always less than 9. So I can select 9 instead of it. So here is how the construction then goes through. So absolute value of X squared minus 16 can be factored into absolute value of X plus 4 times absolute value of X minus 4. Because delta is less than or equal to 9, absolute value of X plus 4, I just took this part and I found that it's always less than a fixed number. It's less than 9 times X minus 4 in absolute value. And this is going to be less than epsilon as soon as X minus 4 is less than epsilon over 9. Do you see that? So my delta of epsilon can be picked to be the minimum of those numbers, the minimum between 1 and epsilon over 9. Are you following? Why the minimum? Because I want the delta to, my deltas are always smaller than 1, right? Epsilon over 9, if epsilon is, let's say, epsilon is 18, then delta would have been, if I just would not have less than 1, delta would have been epsilon over 9, which will be 2, right? But all my deltas are at least 1. So at most 1, not at least 1, at most 1. Good? So here is how the argument is supposed to work. So if X minus 4 in absolute value is less than delta epsilon, then it must be less than epsilon over 9 at the same time. And it must also be less than, so X minus 4 must be less than epsilon over 9 and less than 1. Because delta is the minimum of those numbers, right? So because X minus 4 in absolute value is less than epsilon over 9, 9 times X minus 4 is less than epsilon. Yes, the 9, here is where the 9 comes from. My pipe, my deltas are always, I decided to make them always less than 1. You understand why I can do that? Because what I'm doing with the input pipe, I can always select very narrow input pipes. I will select narrow input pipes because X will be close to 4. X being close to 4 means the X is really coming from a thin pipe. So I might as well say that the input pipes are no more than 1 unit in radius. Does it make sense? Because they are in general, they're going to be thin. I'm selecting a thin pipe centered at 4 here. So I will decide to select the pipe to be of radius less than 1. Are you with me, guys? You understand how I decided why 1? There is no reason. In this case, I could have said 2 or any other number. I just decided to use 1. I could have used 1/2. So in some cases, I will show you an example below where you have to select delta smaller than some size. But here, there is no reason what size it will be. Okay. I just want to say that if they are all going to be thin, I might as well discard all the deltas that are bigger than 1. In my toolkit, my pipes that I'll bring to my construction site will all be 1 unit in radius or less. And if my pipe is of 1 unit or less, then I follow up this construction. I want to know how big can x plus 4 be. So I have that if x minus 4 in absolute value is less than 1, then x minus 4 is between -1 and 1. Yes? And that means that x is between 3 and 5. I just add 4. I don't need x. I need, you see, what I'm trying to manufacture, guys, is x plus 4. This part that causes me problems. You understand the process? Good. But not the process. Understand that I'm trying to manufacture x plus 4. So I get, after the process, I get that x plus 4 is between the numbers 7 and the numbers 9. Does it make sense, guys? Wonderful. X plus 4 is then, this is a number between 7 and 9. And definitely then in absolute value, it's a positive number. So I can put absolute value here, right? So this number is between 7 and 9. And I pick the top number. That's what I will say, right? So this, whatever x is, x plus 4 will always be smaller than 9. You follow? And so then I can have the following construction. If my deltas that I was using are less than 1, then the x plus 4 can be replaced by a bigger number. They're not equal, just a bigger number. So this expression is less than 9 times x minus 4. And I can make this expression easily less than, so this expression I can make easily less than epsilon. I just select x minus 4 has to be less than epsilon over 9. So that it has to be smaller than this number and that number. So I say delta of epsilon will be the minimum of 1 and epsilon over 9. And if I do that, here is what happens, right? So if x minus 4 is less than epsilon over 9, if it's less than the minimum, it's less than both of the numbers, both epsilon over 9 and 1. If it's smaller than epsilon over 9, I get this line. And if it's smaller than 1, I get that 9 times x minus 4 is bigger than this expression. So now you can see, you can put it all together. You can now put it from here to here to here, and I accomplished my goal. Okay, so that means that if epsilon is equal to, let's say, if epsilon is equal to 18, then my delta will be 1. If epsilon is anything less than 9, then my delta will be epsilon divided by 9. Okay, I was able to construct a procedure by which to construct the input pipes. Let's see if you got it, guys. Try to solve this example. You see, x going to -1 of 2x squared minus 5x minus 2 equal to 5. Use delta epsilon to prove that this is indeed so. So Ibad, you have x minus 4 in absolute value. It's always less than 1 in the previous problem, right? That's what we decided, because we decided the delta to be short. It's a hard topic, but I hope you're getting it, guys. Wonderful, Alexa. That's a good step. And then the question is, what's the delta? What delta might you pick? delta is the radius of the pipe. Your goal is to tell me what's the radius of the input pipe to get the current to enter the red pipe of radius epsilon. Well, remember Alexa that if I divide by x plus 1, then the delta wobbles. Different x's give me a different radius for the input pipe, so that cannot be the right answer. That's a good start, Ibad. But so your target is what? It's not just, you're not trying to just repeat steps. You are trying to realize, first of all, what is it that you are doing. Then it's not arbitrary. How big? Well, x plus 1 is it can be made small, not quite x plus 1. We're trying. Oh, perhaps, Ibad, you are thinking the right way. I just want to see what's your delta. So, Dragon, what's the delta? If delta is 2, then you're saying that I never have to shrink my input interval. So be careful, right? You see, guys, here is one thing. A lot of you, the way you think of it, you're just trying to find what do you tell me so that I will say the answer is correct. It's not like that. What is it that we're doing? What is it that you are, do you understand the communication? You see, if you get it, it's like, to me, it's like, again, I do this and I imagine watching a movie, right? I imagine actually landing a spacecraft and receiving communications from it, or trying to hit a target with a water gun, or trying to sink a ship using a torpedo, right? All those, you can imagine so many things and at the same time somehow. We will talk about this one again, right? So think about Zainab. Here is a hint. You can select your input pipe, your delta, to be less than 1, because you're in general your input pipes are very thin. So suppose the delta is less than 1. What do you do then? By the way, guys, you know where to find my notes, right? The notes and the videos are available. The videos are on YouTube. You can check them again if you need to. And the notes are posted on my website. You've seen them, right? You should open those notes and read them after class. All right, so let's work on it together. Here is how we go about it. Okay, so a few of you have factored 2x squared minus 5x minus 7 into absolute value of x plus 1 times absolute value of 2x minus 7. First question, which of those parts do we care about? X plus 1 or 2x minus 7? Please write in the comments. Which parts are significant for me? Exactly, x plus 1, because x is going to minus 1, and absolute value of x plus 1 represents the distance between x and minus 1. You with me? So what do I do next is I'm going to say if x plus 1 in absolute value is less than 1. Now, before I continue and mention, what am I saying by that? Why am I saying if x plus 1 in absolute value is less than 1? And it's not a very complicated mathematical idea. What am I really saying? So I'm a plumber. I came to you to your house and I said, absolute value of x plus 1 less than 1. What do I really mean? I'm just weird. You see, I'm a strange plumber, and I said that. But what did I mean? Well, X is, so if I'm a plumber, I don't really like to say the word X. Of course, I did say something strange there, right? But what is it that I truly mean? If I start speaking plumber language, not math language, but plumber language, what is that absolute value of x plus 1 less than 1 about? Kind of, right? So again, distance. No, here is how plumber speaks. No, probably not like that, but here there, boss. You see, the pipes I'm gonna use are all going to be of radius 1 or less. I'm not gonna use thicker pipes. Forget about it. Yeah, it's just very simple. It's just that the input pipes around -1 that I might install are all of radius 1 or less. That's what it means. And I can select even thinner radius because in my toolkit, well, when I take a limit, I'm going to make the input pipe very thin, correct? So I might as well make it 1 or thinner. So then from this information, if absolute value of x plus 1 is less than 1, I have this calculation that x plus 1 is between -1 and 1. Guys, by the way, let me know, do you understand how I get the first line? Okay, Joshua, where do I lose you? Absolute value of x plus 1 less than 1, it means that x plus 1 is between -1 and 1. How do I know that? X plus 1 is a number. If the size of the number is less than 1, so what is this number? The number is between -1 and 1. Get it? And then x is between -2 and 0. And then I just multiply by 2 and subtract 7. I'm manufacturing 2x minus 7. That's what I try to get rid of. So 2x minus 7 is between -11 and -7. And that means that absolute value of 2x minus 7 is definitely less than 11. So before I move on, do you understand? How did I get 11? Look at it. Up to which line do you understand, guys? Do you understand up to the third line, up to 2x minus 7 between -7 and -11? Do you get it? If so, yes, write yes. Okay, so one person says no. Okay, so I lost some of you. By which line do I lose you guys? Do we understand the first line? So -1 between x plus, so x plus 1 between -1 and 1. Okay. Now I just multiply this by 2 and subtract 7. Do you agree? Multiply everything by 2, so inequality, right? X between -2 and 0. X between -2 and 0, I multiply everything by 2, I get 2x between -4 and 0. Yes, and then I subtract 7. You understand? The numbers keep the same relationship to each other, because if I multiply everything by 2, I get -4 and 0. So I get -4 less than 2x less than 0. And then I subtract 7 and I get this line. Are you with me, guys? Can you carry out the calculation there? This is inequality, right? So, and you, Alexa, good or still not, right? You just multiply everything by 2 and subtract 7 from everything, and the inequalities are preserved. Yes, wonderful, good. And then I have that this number 2x minus 7 is between -11 and -7. So it means that the size of this number, its absolute value, is definitely less than 11. Are you with me at the last line? It's only inequalities there. right? Because if the number is between -11 and 7, its size, when I take absolute value, I'm saying the magnitude of this number is definitely less than 11. Because the magnitude of this number is between magnitude 7 and magnitude 11. So I take the bigger of the magnitudes. So 2x minus 7 is less than 11. No, I mean, well, if you can think of it this way, but I'm just thinking, okay, 2x minus 7 is a number between -11 and -7. What is the biggest magnitude this number can achieve? And that's the absolute value thing. The biggest magnitude can be 11. You can think of it otherwise, but that's it's just intuitive. So you're choosing values. Zainab is asking. So you're choosing values greater than and less than the limit -1 and creating inequalities from yes. Well, I create inequality from the right. Yes, I pick the bigger number. Correct. But that's a procedure. You see, if you memorize procedures, it's not helpful. Understand what is that? What's the idea that we're trying to communicate here? So absolute value of 2x minus 7 is less than 11. And so now I have absolute value of x plus 1 times 2x minus 7 is less than, if delta is smaller than 1. I can replace this by 11. 11 times x plus 1. And that will be less than epsilon if delta is also smaller than epsilon over 11. Right? If x plus 1 is smaller than epsilon over 11, then this inequality is true. So then my delta of epsilon will be the minimum between 1 and epsilon over 11. Why subtract 7? Because I have here I have 2x minus 7. You see, I'm trying to get rid of the number in absolute value that's multiplying the expression that I care about. So we have this, and so I take delta of epsilon to be the minimum between 1 and epsilon over 11. Good. Wonderful. I will skip this more abstract example. You can look at it later on your own. So again, some of you have asked, why do I pick 1? I could have picked 3, 1/2, etc. The idea of this argument, there's not a unique delta that I'm constructing. I just need to construct a procedure that tells me if I have this whatever target pipe, what should be the size of the input pipe so that the currents go from blue pipe to the red pipe. The notes, Dragon, is on my website, etkin.com. So you should go there and see. So here it is. You should visit the website and look at the notes. That's why I write them. Okay. So here is, so in general, I can pick delta to be less than 3 or less than 1/2 or less than 1 over 100 because the radius of the input pipe is supposed to get very thin. Okay. So here is the next problem. I'll show you that here it might matter which deltas I pick initially. I cannot pick delta equal to 1 initially because of the following thing, right? So limit as x goes to 1/2, 1 over x is supposed to equal to 2. Now, that means that my current is coming from 1/2, but 0, I cannot plug 0 into 1 over x. So it's a dangerous value, right? So I will never, my set of delta, my toolkit for delta will have to have radius smaller than 1/2 because I don't want this infinity point. So I will take my delta initial to be less than or equal to 1/4. Because you see, the biggest delta I could pick here is 1/2 because it's 1/2 minus delta, 1/2 plus delta. I don't want to include 0 as one of the inputs that I'm plugging into my machine because it's not able to digest 0. So here I work with deltas that are, I decided to work with deltas that are 1/4 or less. Not 1 as I did before, but 1/4 and less for this example. And so how do I solve this? I can begin absolute value of 1 over x minus 2. It's the absolute value of 1 minus 2x divided by x. I can factor out minus 2 over x here, factor out the absolute value, and I have, this is my residue, my garbage that I want to get rid of. It's 2 divided by absolute value of x times absolute value of x minus 1/2. And I know that absolute value of x minus 1/2 is less than 1/4. So that means that x minus 1/2 is between minus 1/4 and 1/4. And that will imply that x, by just doing the algebra, x is between 1/4 and 3/4. Are you with me, guys? It's a bit tiring, but I hope you are still able to follow. No response means that what? Completely lost? All right, so it means that you are tired. So what I think we will do, we will stop the delta epsilon for today, and we will begin the next topic, and we will return to the delta epsilon on Tuesday. Okay, so that you can digest it a little bit better. Okay, sounds good. Do you want a short break, 3 minutes? Take a short break of 3 minutes, and we will go and talk about the next lecture notes, and we will return to delta epsilon a little later so that you're not entirely fried. Well, you go to Math 150 calculus and you open it, there will be Corona notes. No, but you can talk about them with me. I think there are some answers. You can check what answers I have. There are answers to prior solved exams and some assignments. Again, guys, I recommend that you open the textbook. We are right now in, let's say, 2.2, 2.3, 2.4, and you can look at the odd problems. The odd problems have solutions at the back of the textbook, and you can just check if your answer is right. So guys, you should have looked through the website and just click on what's available under Math 150, Calculus 1. That's the title of the course at Hunter. So you can look and see what's there. You can find a bunch of solved assignments, prior exams. You can look through textbooks. We still have covered very little. All right, guys, so maybe one more minute and let's return to the material. When, by the way, remind me, this class is over at 1:05 or 1:15? I don't remember for a moment. Okay. Thank you. Well, let's return to let's actually keep to another topic. We'll return to delta epsilon later on. Can you hear the sound, guys?
So now, I want to sing a song just for you. 'Cause you're my special friend.
Now my question is this: why was it scary? I mean, maybe you were not that scared, that but I didn't pick something terrible. But why was it scary? Can you tell me? Well, it wasn't sure. I mean, but I could have picked something else. I just didn't know how you respond to it. But because it was unexpected, Alexa says, right? I'm not asking it out of the blue. Let me explain to you what is it that I'm asking. The loud sound, perhaps, but if you came to a concert and you hear a loud sound, you're not necessarily scared. So that's the next topic. It's continuity. Okay, so what happened? There was a discontinuity between, and they use it in horror movies all the time. So, something was happening very, very, not even rapidly, instantly, perhaps. You know this this common horror theme, right? So you have, let's say, you are in this room, the light is flickering, and you see some scary figure very, very far away in the hallway, right? So the light flickers on and off, and the figure is staying very far from you. Can you imagine? I would do it in person if we were in class, right? So imagine that I stand there in your hallway, and the light turns off, you see nothing, it turns on, and I'm very far. Turns off, turns on, and I'm very far. And suddenly turns off and turn on, and this monster is in your face, right in your face, like this. Why is it scary? Because there was discontinuity of motion, right? The person was far, and instantly the person is close. And then what is it that we call continuity is the topic that we want to examine here. Okay, so roughly speaking, when a function f of x is continuous, we imagine that the graph is a whole piece. It can be traced without lifting the pen from the piece of paper. So here are some examples of discontinuous functions, and what we try to investigate is exactly what goes wrong. So tell me, guys, what goes wrong in, mathematically speaking, in 1, what goes wrong in 2, what goes wrong in 3, what goes wrong in 4, which of those curves are the most discontinuous, the most not one piece like? So there is 1, 2, 3, and 4. And the more interesting question is what exactly is not whole about them, right? Mathematically speaking. So let's see. So in number 1, notice that that there is a hole in this curve. So you see, I go, I trace it, but here is a hole. I have to lift my pen and continue tracing it onwards. So the idea that there is a hole, it means that the function cannot be evaluated at A. Okay. Now in the next case, in 2, look what happens, right? So there is not only a hole, but look at it. If I trace from the left, I get to one location, and if I trace from the right, I get to another location. We don't have a match, right? So it's like my fingers, if I trace it on both sides, they don't meet. So there is a tear at A, right? So at A, I'm on the one hand, on the left, I'm up, and here I'm down. Here in 3, when you say an asymptote, what you have a tear, and we go to infinity on the left. So my finger, when I draw it, goes up forever, and on the left goes up forever. So for 3, the limit as x goes to A of the function h is plus infinity. You see, we go from left and from the right, we get plus infinity. Does the limit exist, by the way, when I get plus infinity? So on this, right, it actually, we consider a limit to exist if when we have convergence to a number. Plus infinity, it's just a tendency. It means that we're getting bigger and bigger values, but not actual number, so that the limit does not exist. In terms of the water gun, when they approach A, the current will just go higher and higher and higher. All the particles, eventually they're hitting higher and higher and higher. You understand? So so you're not focusing the current around one point. You're just it's like if you're a fireman and you're spraying this water, it's like you're spraying up and up and up, and the water goes higher and higher and higher. Eventually you don't see it. What's the idea in 4? In 4, the limit from the right exists and it's equal to k, but the limit from the left, you see, I go up, down, up, down, up, down, and this is supposed to be forever. So as I go on, there are more ups and more downs. So the limit is, so the current is not focused. You see, some particles always fly up and down, up and down, up and down. I'm not focusing this particles that are around the point. So all of those are examples of discontinuous functions. Okay, and here is what it means for a function to be continuous at one point A. It means that if I take a marker and I trace from the left, I will get to this whole point, and if I trace from the right, I'll get to the same point. And we can capture that mathematically. You have to understand or agree or disagree, by the way. You're allowed to disagree. Do you understand why that is supposed to capture the limit mathematically? Right, at A, if I'm saying that the curve is connected at A, it means that if I trace the curve from left and from the right, I arrive in this location. They are meeting. So left limit and right limit are meeting. You see, when I make the trace, when I go here, I'm tracing on the left with a pencil, and if I trace the curve on the right with a pencil, the pencils should go into the same location. That means that the limit exists. And the location where they go, I have a solid point there. So that's f of a. So that means that in terms of algebra, whenever a curve is continuous, applying limits or plugging in the value a gives us the same result. That's algebraically what it means for the limit, for a function to be continuous at a point. Now, a function is continuous from the right. So for example, this is it's continuous at this point from the right, because I see there is no left part of the curve, but if I move the marker to the right of this point, I'm going into the point, and it's continuous on the left of this point because I can move the marker from the left of that point and it will merge to the location, whatever that location is here, right? So that's continuity from right and continuity from the left, okay? Now, the thing about the curves here, you can actually see the curve, but very often when you're giving a formula, that is the same as not seeing the curve. You don't know what it looks like. You just imagine it's a string, and that string is not visible to you, but it's one whole connected string. So here is the question. where are the following functions discontinuous? Okay, so you have function A, function B, function C. Where are those functions discontinuous? You understand what I mean? So if you were to draw those curves, they will look like strings with possible holes or tears in them, and you need to know where the function fails to have, where the function has a hole. Before, by the way, you answer this question, guys. One thing I always worry about: do you see intuitively why limit as x goes to a of f of x equals to f of a means that the function is continuous at that point? What are you trying to capture? Again, is this idea, right? So that if you move x to a, you're tracing the marker from either left or right towards a. That should they should from right and left merge in the same point. If the left and right marker merge in the same point, that means we have the limit existing, and the point where they merge has to be a solid fixed point. Here, a solid point. So that means it has to be f of a. So that statement is supposed to capture the idea of wholeness at this one point. So back to this problem, where is a not continuous? Because the denominator is 0, correct? At 2. So for a, let's just see a. If I plug in 2, it's undefined. As soon as it's undefined, means I have a hole. Good. However, look what happens if I is this a tear or just a hole in this fabric, in this string? What I do is I trace from left and right at the same time. I'm just tracing where is it going. Look at it. X squared minus x minus 2 can be factored into x minus 2, x plus 1. And if x approaches 2, I can cross out x minus 2, and I get that the limit is 3. Using limit laws and whatnot. You agree? By the way, because it's a rational function, the limit as x goes to any value a will be f of a as long as a is not 2, because I can apply the limit laws for product, sum, and division, right? Because limit of a quotient is the quotient of the limits, and both numerator and denominator always exist at any a. I just need to plug it in. And the only time the quotient law fails to work is when I divide by 0. So the limit is 3. So so what does it mean? Even though I do not know what the graph looks like exactly, I haven't drawn it. Actually, it would look like x plus 1. It would look like a line. But forgetting that for a moment, we have a 3 here. So the situation is it's a discontinuity of this type. It's, by the way, called removable discontinuity, because all you have to do is fill in that one point. So it's this type of discontinuity where the limit does exist. You follow? Good. What about B? What can you say about B? Where is B discontinuous? B is defined everywhere, but where is, Kirill, where is the function discontinuous, or is it continuous everywhere? where is B discontinuous? Remember, guys, that when you check for continuity, it's not enough to know that the function is defined everywhere. What you have to have is this situation, right? So defined everywhere means that there is a point here, okay? So there are examples I think I gave where it was defined everywhere, like here. It is defined everywhere. Do you see that? At A, it's defined to be M. So at it's, by the way, you see, but at A we have a discontinuity. The curve is torn apart. Why is it torn apart here? It's because the left limit and the right limit are not the same. This, by the way, is a right continuous function because look at it. Any point on the right that I select, it's continuous everywhere except for A. And if I look at A, if I take the right hand limit, I get the same value as G of A. So Ibadi is continuous at every point except at 0. And why is it discontinuous at 0? Well, we can take the limit as x goes to 0. If x goes to 0 of 1 over x squared, it's like 1 over 0 plus. You know, this means an imitation of 0. I plug imitation of 0 instead of x, I get 0 plus, and the answer is infinity. Yes? Now, what about, so infinity means the limit does not exist. So it's a discontinuity somewhat of this type. Even though it's defined at A, it's somewhat of this type of discontinuity, type 3. Maybe it's defined to be 1, like where I'm hovering with my red cursor. But otherwise, it doesn't matter. The limit does not exist, then the function cannot be continuous. Limit not existing, it's a worse type of discontinuity. So I would say this is a mild type of discontinuity. This is a little bit worse. And 3 and 4 are very bad discontinuities, right? So perhaps 3 is the worst discontinuity since neither left nor right limit exists. Well, definitely 4 is quite bad because the left limit doesn't even, definitely the left limit does not exist, okay? But probably 3 is the worst here because there is no limit from either side. When so the lines don't meet near a fixed point, yes, something like that. There are no numbers that you're getting. We will talk about infinity rather soon. Okay, good. So what do we have now? So we are at C. Is this function continuous? Notice it's very similar to A. Is C continuous? This was not defined at 0, but C is defined at 0. So for C, notice if I want to use 2, I'm not using the top equation because top equation only works when x is not 2. When x is 2, the answer is 1. The function is defined to be 1 at 2. Is the function C continuous or still not? So Stephen then says now it is continuous. Do you agree? So Alexa says continuous everywhere except 2. And Christian, so you say yes, but yes to what? To Alexa or to the previous thing? So continuous everywhere or not continuous at 2? So say continuous if it's continuous everywhere, or say not continuous at 2, just not 2. Okay, Ibad. Again, let's look at it. We already covered this limit. What's the limit as x goes to 2? It's the same formula here, right? If x goes to 2, the limit should be 3. But 3 is not 1. So the limit is not the same as where the function is defined, which means the function fails to be continuous. This should have been defined, this should have been defined 3. This should have been a 3. If it were a 3, the function would have been continuous everywhere. Does it make sense? Because the limit at each point must be the same as if you just plug in the value. So f of 2 is supposed to be 3 because the limit as x goes to 2 is 3. And here is the next function. The next function is greatest integer function. This because roughly like this, right? So but f of 2.0001, it's roughly 3.001 exactly, right? So that's the situation. The values very close to 2 are not close to 1. So that means there is it's a scary situation. You understand how it relates to that horror? So this function is a little bit frightening in the sense that at values close to 2, you are far from 1. But suddenly at 2, you are at 1. So there is this instant jarring motion. Suddenly you are in one place and in the next you are teleported right somewhere elsewhere, right? Good. So now let's think about the greatest integer function. Let me just explain to you what this function is. It rounds every number down to an integer. So for example, 3.1, the function will make into a 3. 5.9, it will make into a 5. It's like a floor function, right? So if you are between two integers, you always fall down to the integer slightly below. F of minus 0.01, integers below 0 minus 0.01 are minus 1. It's a minus 1. You agree? And the function at minus 5.9, what's the integers directly below minus 5.9? It's minus 6. So you always move to the previous integer from the expression. Good? You understand what this function is doing, guys? Greatest integer function. Make sense? Not such a stupid function, by the way. I can show you a very cool physics application with this function. And now the question is, where is this function discontinuous? You understand my question, guys? Where is this function not continuous? At 2, yes, that's one point where it's not continuous, but what's the total number of points where it's not continuous? Which are those points where it's not continuous? You see, you can possibly draw this picture if you want to try to draw it. For you see if you can draw this function. It's not so hard to do so, but you can also reason blindly. Mostly what you do is you grope around this curve where it's continuous, and you grope around it blindly, because that's what I mean by that, because I just have the formula, but it's not in front of my eyes. Very nice, Reiki. Integers, it's definitely not continuous. So what are you doing, guys, if you are stuck? Okay, try to graph it. It's all possible. You need to become like a U-boat commander. You need to be blind. Interestingly enough, about U-boat commanders, my birthday happens to be the same as that of Karl Doynitz, who was the admiral for naval admiral for in command of all the U-boats and all the naval forces. So what you do is you are reasoning when in naval warfare or in artillery, you reason blindly. So you have to figure out how to know whether you have a hit or a miss and how to target without having anything in sight. Okay, that's very similar to what happens over here. So here is how you can reason, right? So take a typical number A. So I did not want to graph. I just picked a typical number A between n and n plus 1. Here is n and n plus 1 are two integers, right? So let's suppose I pick a number that's not an integer, so it will be between two integers. Do you agree? Let me know if you are with me. You understand? I use blind reasoning sometimes, right? So this is very easy to graph, but most things are too complicated for you to be able to visualize them necessarily, right? So you are using blind targeting. Okay, so what happens there, right? So you see what happens if I move to A from the right. You see I'm moving from the right. What happens to this point? It's a floor function. So all the points in this interval are collapsed to n, correct? So as I move my x, eventually it enters into this interval. Right here, it's entering the interval from the right. What's happening to it? It's mapped to n, mapped to n, mapped to n, right? So so what happens? The limit as x goes to a from the right is n. Good. And if I do it from the left, the limit is also n. You agree? So that means that limit as x goes to a when a is not an integer is the same as f of a, because they're all mapped to n exactly. That means the function is continuous at every point that's not an integer. Are you with me? You understand how I reason? Without any graphing, I just kind of said, okay, floor function means you drop always to the lower integer. So I picked integer and non-integer. What happens if I pick an integer? So if I pick an integer, what would happen? Let's say this is my integer, right? What happens if I move to from the right? From the right, I get that same integer. Do you agree? A function at an integer is that same integer. And if I pick something above from it, it's that same integer. So that's continuous from the right. Do you agree? Because limit from the right gives you the same thing as plugging in the value, no matter whether integer or not. If it's integer, it always works. And if it's not an integer, the function is continuous to begin with. But I see there is continuity from the right, because limit as x goes to a number plus is always that number. You understand how I reasoned? Because it's true for non-integers, and for an integer, clearly, if I move from the right, it's the same as if I plug the number. Okay, what happens if I push a limit as x goes to n from the left? If I move from here, what happens? What's my limit if I move to this integer n from the left? Please let me know. You might actually see it, right? What happens? So no, it's not. Yeah, exactly. So it's n minus 1. If I move from the left of n, I'm always dropped back. So for example, if I take limit as x goes to 1 minus, what am I getting? I'm always getting 0. Do you see that? If I approach 1 minus, in other words, slightly below 1, it's the function always drops me to back to the floor, to 0. So limit as x goes to any integer from the left is that integer minus 1. So left and right are not equal. That means the function is discontinuous at every integer. It is continuous at every non-integer. And it's also right continuous on every integer. Right continuous means that this limit is the same as limit from the right is the same as plugging the value in. You see that? You can graph it, guys, but you understand how I reasoned, yes? I reasoned without using graphs. All right. This is just a trivial example here. We will show that this function fx, which is 1 minus root of 1 minus x squared, is continuous on the closed interval from -1 to 1. So this is just an application of limit laws and the fact that limits can commute into roots that we will maybe see later on with derivatives. I can give you an argument for why that's the case. So if the number at which I'm calculating the limit is between -1 and 1, by the way, guys, see, I'm speaking about this. What is it that I'm trying to show? When I say show that the function f of x equal to 1 minus root of 1 minus x squared is continuous everywhere, very simply, what is it that I'm trying to do? You see, when it's very formulaic, then you don't see it. Maybe what I'm asking you is a bit vague. You see, this function, it has a graph. F of x equal to 1 minus root of 1 minus x squared. There is a graph, correct? And I'm asking you, what is it that I'm trying to show about the graph without even seeing the graph? Well, value is not continuity. What is continuity there? You see, it has to be very simple, guys. That is continuous. What does it? What am I trying to say exactly? That what am I saying about the graph? Well, you think about it. You see, when you speak with such mathematical terminology, I think right away, well, you're not seeing it. It's just very simple as grass is green. It's you're trying to take a string and you're trying to show that the string is one whole piece. You understand? This function has a graph. Because I haven't graphed it, that means that the graph is invisible to me. This is actually an easy graph. I can do it, right? I can draw a picture for it. It looks like, you see, root of 1 minus x squared looks like the upper part of the circle. Because I have a minus, it looks like the lower part of the circle. So it's the lower part of the circle lifted by 1 unit. I can clearly see what the shape here is. But the idea is, in general, you have complicated functions and they have and the graph is very complicated. So it's like a string that is twisted in a complicated shape on a flat piece of paper. And my goal is to show that the string is one whole piece. Because I cannot see it, it's transparent to me. I just have to argue that it's one whole piece. Because if I'm not producing a picture of it, and pictures can be extremely complicated. I can show you how complicated they can be. Yes. So then yeah. I'm just trying to show that this is a one whole piece. At any rate, we are out of time for today. I would like to say the following, guys. If you would like to understand delta epsilon as quickly as possible, you're welcome to join with my evening section. I will discuss the delta epsilon with them again. And the notes are on my website. And please start, please start solving problems. Time is 6:05. So if you want to join, guys, you have the syllabus over there. 6:05. You have the code. You have everything you need. You are welcome to join. Okay. There will be an extra credit on the exam. I will not make it the easiest extra credit. And if you answer it, I might actually ask you questions about it because I want you to. Well, I want to be sure it's your answer. If you understand those things, you really advance in your mental capacity. That's what I really hope you do. So problems again, guys. I'll stop the recording.